So slope is the ratio of the vertical change to the horizontal change. We call that the rise over the run. Okay? Well, if you look down below that, you have a key concept for slope. So slope can always be calculated between any 2 points on the line, and we call that just the first point and the second point. Or the way we write that is with subscripts. Okay? So x sub 1, y sub 1. By the way, I'm saying sub, S-U-B. A lot of times people think when I say x sub 1, they think I'm saying x of 1 or y's of 1. That is not what I'm saying. Okay? It's x sub 1, meaning x subscript 1. Okay? The subscript just tells us that x sub 1 is different than x sub 2. There's still x coordinates, but they're different numbers. Okay, that's why we put the subscripts there, just to keep our variables straight. Okay? So we have 2 points, first point, second point. And we know that slope is rise over run. Well, for the formula purposes, you guys all know it's rise over run. For the formula purposes, I want you to think y's over run. Don't think rise over run, think y's over run. Because that then reminds you that the y's always go on top. Because that's a common mistake students make, is they see that the x coordinate comes first, and so they immediately want to calculate the difference of the x's on top. Don't do that. The y's go on top. Okay, it's y's over run. All right. Second thing, what variable did you always use in Algebra 1, or in geometry for that matter, for slope? We always use the same variable for slope every single time. It was what? Do you remember? M. M is slope. Mathematicians many, many moons ago came up with that, and it's the way it is. Okay? All right, so M is slope. So our slope formula, yes, slope is rise over run, but the formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is our slope formula. If you have 2 points given to you, you can find the slope between those 2 points using this formula. Okay? A couple of pitfalls. A couple of places students commonly make mistakes. Okay? First off, again, like I said, y's over run, right? It's always the y's on top. Second thing students have a hard time with is the points. There's 2 points, a first point and a second point. It does not matter which one you call the first point and which one you call the second point. That doesn't matter. Okay? But what does matter is the order in which you put them in the formula. Okay? Notice where these points are located in the formula. X sub 2, y sub 2. They're above and below each other in the formula, right? They come from the same point. Y sub 1 and x sub 1. Again, they're above and below each other in the formula. They come from the same point. That part matters. If your coordinates end up crossing, if you have y sub 1 here and x sub 1 there, you're going to get wrong answers. Okay? Each coordinate cannot cross each other. They have to be above and below each other. It doesn't matter which one comes first and second, but they have to be above and below each other. Okay? Questions on that? Now, again, what I mean by they have to be in the same right order is it could have very easily have said that we have y sub 1 minus y sub 2 over x sub 1 minus x sub 2. That's fine. That'll still get you the same answer. But again, notice, I have my coordinates for the first point above and below each other. The coordinates for my second point above and below each other. That has to be true. Questions? Nothing yet? All right, let's go ahead and try an example. Right next to this we have a couple of examples. We'll do letter A together. So we want to find the slope of the line that passes through these given points. So the first thing I'm going to do is write down my formula. my slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And just to help you out, and again, I'm trying to give you some strategies to help you get the right answer every time. Above your points, you get to pick whichever point you want to call point number 1. Doesn't matter. You pick whichever one you want to call point number 1, and above those coordinates, you write x sub 1, y sub 1. Because that's going to be your first x coordinate and your first y coordinate. The other point, again, whichever one you choose to be your second point, is then x sub 2 and y sub 2. Now you use those values to plug into the slope formula. So y sub 2 is 4, y sub 1 is 7, so we have 4 minus 7 on top. X sub 2 is negative 2, x sub 1 is negative 3, so we have negative 2 minus negative 3 on the bottom. Don't mess with the signs yet, just plug in. Okay? Now that we have it plugged in, now we can mess with the signs. Question?
It's not just minus 3.
No, because x sub 1 is a negative 3. Right? So it's got to be minus a negative 3. Okay? Don't mess with the signs yet. Now that we have it plugged into the formula, now we can mess with the signs, knowing that we have minus a negative, which means we have plus 3. Right? So, 4 minus 7, negative 3. On the bottom we have negative 2 plus 3, positive 1. So what is our slope? Negative 3 is our slope. We do need, for graphing purposes, we need to know that it's negative 3 over 1. But as far as plugging into equations and working with the slope, negative 3 is what we want. You guys got to get past wanting to put 1s around everything. Okay? I'm checking your tests, and I'm still having people that are giving me the answer of 2 over 1 plus and minus 3i over 1. It's supposed to be an I. But of course, now I can't erase it. There you go. Okay? 2 over 1 plus and minus 3i over 1. Is it wrong? Technically, no. But I thought high school students didn't want to do more work than they had to. By writing it over 1, you're doing more work than you have to. The answer is 2 plus and minus 3i. You don't need to put it all over 1. Okay? It's unnecessary, so please stop writing it. Same thing here. If I ask you for the slope, the answer is not negative 3 over 1. The answer is negative 3. Okay? So, that being said, please go through and work examples B and C. So in example B, first thing I'm going to do is decide first point and second point. And just for giggles, I'm going to say that this is my first point. Just to show you guys that it doesn't matter which one you call your first and which one you call your second points. Okay? So, y2, y1, I have 1 minus 1 over x sub 2 is 3 minus x sub 1 is negative 4. Well, 3 minus a negative 4 is 3 plus 4. So my answer is 0 over 7. Do I leave my answer like that? Is that reduced? No, it is not. What's 0 divided by 7? 0. So my slope is 0. Okay? In part C, again, deciding which point is your first, which point's your second. So x1, y1, x2, y2, and we have 1 minus negative 3 over 7 minus 7. So 1 minus negative 3 is 4, and 7 minus 7 is 0. So what's my answer?
4.
Do you remember?
No, 0.
Do you remember? This is undefined.
Because it has a rise but no rise.
0 is under 4, it's undefined.
Because 0 is in the denominator. You cannot ever, ever, ever divide by 0. Okay? It doesn't work. Like this one up here, we have 0 divided by 7. I can take nothing. I can take 0 things and divide it among 7 people. What does everybody get?
0.
Nothing. Yeah, aren't I generous? You're welcome. Okay? 0 over 7 gives me 0. Everybody gets nothing. Whereas if I have 4 things and I divide it among nobody, I can't do that. I can divide 4 things among one person. That one person gets all 4 things. I can divide 4 things between 2 people, or so on and so forth. But I can't divide 4 things among nobody. There has to be somebody there to receive it. Okay? So we can't do that. That is undefined. Now, what is the significance of these slopes? Let's take a look at the bottom here where we have a couple of graphs being shown. Okay? So, a positive slope, if you calculate your slope and you get a positive number, your slope will rise as you read from left to right. As you look at this graph from left to right, your slope will increase. The line will increase. It will be going up. That's a positive slope. Whereas a negative slope, if you're going from left to right and it's dropping, that's a negative slope. As I said at the beginning, if you have a slope of 0, 0 slope does not mean no slope. Okay? They're kind of different terms. 0 slope literally means your slope equals 0. Okay? That's like the floor. The floor is not steep, so this floor has 0 slope. Okay? So that's a horizontal line. Now, a vertical line, I like to think of that as being so steep we can't comprehend it. Okay? A vertical line is so steep we can't comprehend it, so that's where that undefined slope comes into play. That's when you're dividing by 0. You get undefined slope. Okay? Questions on the 4 types of slope? No. I'm hoping all this is review from Algebra 1. So let's take a look at the big key concept for today, being slope-intercept form. Slope-intercept form is right there. Y equals m times x plus b. Please remember, mx means m times x. It's not together. It's not one thing. It's not mx. It's m times x. Okay? So, right above that I have a graph for you. I want you to take a look at that graph. We're going to do some detail work here. I'm going to tell you about slope-intercept form, give you a little cheat sheet for slope-intercept form. So slope-intercept form is y equals m times x plus b. Okay? Next, what I want you to do is I want you to draw a line, but don't just draw any old line. Get out a straight edge. Now, when you draw lines for me, I want you to always draw straight lines. That means you need to get out an ID, you need to get out a driver's license, you need to get out a debit card, you need to get out your baker's card. I don't care what card you're getting out. Get out something that has a straight edge. Heaven forbid you might actually have a ruler on you. Get out something with a straight edge so that we can draw straight lines. Okay? So, once you have that out, I want you to draw a straight line. It doesn't have to be exactly like I have mine, but it needs to be somewhere in the graph, and it needs to look something like this.
You can use a ruler on it.
You sure can.
Is that a rainbow color?
No. Okay. So, there's our line. Now, the pieces of slope-intercept form. There are 4 variables, 4 letters in slope-intercept form. Each of them means something. So this little graph is going to show us what each item means. So if you take a look here, one of the more important points on a line is where it crosses the y-axis. So that point right there is our y-intercept. That point is always located at 0, comma, b. Always. Okay? Something else that is extremely important about our line is the slope of our line. The slope of our line can always be calculated by counting from one point to another point. We count the rise and we count the run. Remember, it's the vertical change and the horizontal change. We call that rise and run. This is the rise, and this is the run. Okay, and that gives us our slope. And that's calculated between any 2 points on your line. Okay, so we have now talked about the b in our equation. We've now talked about the m in our equation. The last thing is x and y. X and y, 90% of the time you see this, x and y are just going to be that, x and y. You're not going to have numbers in there. Okay? The reason is because x and y stands for every single point on our line. Every single point on our line has an x and a y coordinate that fit into that equation. Okay? So that right there are all the pieces for slope-intercept form. That is how we're going to graph lines. That's how we're going to write the equations of lines. All right? Any questions? Yes, sir.
So x and y can be any point?
Any point on that line. Yep. Any other questions? No. All right, let's go to the next page. Look at. All right, we talked about the x-intercept. We talked about the y-intercept. Let's go right next to those. Right next to those, we want to write this equation in slope-intercept form and then identify the slope in the y-intercept. So writing this equation in slope-intercept form means we want it written as, y equals, messing stuff up here. We want this written as y equals mx plus b. So we need the y by itself on the left side. So if we want to solve this equation for y, what's the first thing we need to undo? No, actually. We need to get rid of addition and subtraction. Because remember, PEMDAS, we work PEMDAS from left to right, meaning we do parentheses, then exponents, then multiplication and division, then addition and subtraction. When we're solving an equation, we work those backwards. So we first undo any addition and subtraction. So we've got to subtract 5x from both sides. Now, how am I going to write that? Am I going to write 16 minus 5x?
No, 5x plus 16.
Negative 5x plus 16, because I want to write it in slope-intercept form. mx comes before the b. So negative 5x plus 16. And now I need to get rid of the negative 4, and so I will divide everything by negative 4. So y equals, now a negative divided by a negative is a positive 5/4 x, and 16 divided by a negative 4 gives me negative 4. So, what is our slope? 5/4, yeah. What is our y-intercept? Now I want to know what the coordinates of the y-intercept is. What are the coordinates of the y-intercept?
0, -4.
There we go. 0, comma, -4. And there we are. Questions? No? Doing all right? Okay, cool. So let's try another type of problem. Next type of problem is going to be down here, example A, under writing linear equations. We want to actually write the equation of a line. They tell us m equals 1/5, and they tell us the y-intercept is at 0, -3. We want to write the equation in slope-intercept form. So that means we've got to substitute in for m and b. Well, what are we going to plug in for m? 1/5. What are we going to plug in for b? Yeah, b is -3. So our answer here will be y equals 1/5 x minus 3. That's it. Yep. That's it. Any questions?
So we're relearning algebra.
Well, for the first couple days, we're relearning algebra. We're not relearning, we're reminding ourselves about algebra. Okay, one more type of problem you're going to see. Graph it. All right, so first off, we are given the equation -2x plus y equals 1. Looking at that, can you tell me what the slope is? No. Can you tell me what the y-intercept is? No. We have to first rewrite it in slope-intercept form. So what do I need to do? Add 2x to both sides. So y equals 2x plus 1. So if y equals 2x plus 1, what is our slope? 2. Now, I need that as rise and run, so it's 2 over 1. 2 over 1. Okay. Where's our y-intercept? 0, 1. Excellent. Excellent. So, in order to graph this, the first thing we do is graph our y-intercept. So off on our graph here, we got to go to 0, 1. Okay, so there's our point. There's our y-intercept. Now, from that point, we count our slope. Our slope is 2 over 1. That means we have a rise of 2. That's positive, so that means we're going up. And we have a run of 1. Again, that's positive, so we go to the right 1. So from this y-intercept, I count up 2, right 1. Brings me right here. Okay, well, I want to do that multiple times because I want a good straight line. So I'm going to go up 2, right 1 again, up 2, right 1 again, up 2, right 1 again. But slope is like stairs. Okay? Can you just walk upstairs? No, you can also walk downstairs. Otherwise, we'd all be stuck in our attics. Okay? So we can walk downstairs as well. Same thing with slope. We have 2 over 1. Well, I could rewrite that as -2 over -1, which means I could count my slope going down 2, left 1. Okay? And notice when I do that, I still get the same line. I still get the same slope. So we grab our straight edge and we do our best to draw a good straight line through those points. And there we go. We have graphed it. Questions? Yes, sir?
We had a problem with this on the quiz. You go and look.
Oh yeah, I'm going to look to make sure that you have your points drawn correctly and your line goes through your points. Yep. Yep, don't slough through this, folks. Draw good straight lines. Make sure your points go through your lines. Okay? Good to go?